Okay, this section is all about areas of polygons and circles. Make sure I'm recording. Yeah. So we're going to look at how to find areas of rectangles, parallelograms, triangles, kites, trapezoids, regular polygons, circles, and sectors of circles. We'll look at how to find conversion of area units, and then we'll look at how to find the ratio of area measures of similar figures. Okay, when you find the area, sometimes this may be an activity that you may use with your students, but there's something called a geo board. And if you're wanting to find the area on the geo board, then you're going to divide the area into smaller pieces and then add the areas. Okay, so if you're wanting to figure out the area of this figure, this is one example of how you can divide the area up into smaller pieces. You can tell that this tan colored here would have an area of 1, 2, 3, 4, 5, 6. So you're just going to count how many squares there are here. Then you have 7, 8, 9, 10 in the purple, and then 11, 12, 13, 14 in the darker green, 15, 16 in the lighter green, 17 for that brown, and then all of the halves. So these two together would make 18, and then the lighter tan with the green would make 19. And so you have 19 square units. Okay. Now here's another method where you kind of do the opposite. You're going to, this is called the rectangle method. You would construct a rectangle by encompassing the entire figure, and then you subtract off the areas of the unshaded regions. Okay. So they're showing you here, if you look at this, once you draw your rectangle, if you look at it, the area would be 16, and then you're going to subtract off the area of the non-shaded parts there. Okay, and then here's an example of how you would do that. Okay, you can see that you have some half areas here that you're going to end up subtracting off. Okay, converting metric units of area. So when we're talking about area, we're going to have square units instead of just units. So here's a chart that you might refer to, showing you what the unit is, the symbol for the unit, and then what the relationship would be to a square meter. And then on this next problem, we're going to look at converting different metric units. Okay, so on part A, we want to convert 5 square centimeters to 1 square millimeter. Okay, you can use the chart to see which way to move your decimal that we talked about back in 13.1. Okay, you can also set up a multiplication problem. So when we know that 5 centimeters is what we're converting, and our units of measure, when we look at our chart back here, we have 100 square millimeters would be equal to 1 square centimeter. So I would multiply. Remember, you want your same units to be able to cancel out. So the 1 square centimeter needs to be in the bottom of the fraction so that your square centimeters will cancel out. That leaves you with 5 times 100, which would be 500 square millimeters. Okay, 124 million square meters to kilometers squared. When you're working this one out, your meters need to be able to cancel. So you're going to put the square meters on the bottom, leaving square kilometers on top. And so now you'll multiply 124 million times 0.000001. Okay. So this just means that I'm going to move my decimal 1, 2, 3, 4, 5, 6 places. So that would basically cancel out all your zeros there. Okay. So you can use this chart to help you figure out what to multiply by. Okay, next we've got converting English units of area. So 1 square foot is equal to 144 square inches. Okay, so remember 1 foot was 12 inches. So since we're talking about square units, you're just going to square the 12 to get the 144. Okay, 1 square foot is also 1/9 of a square yard. Okay. And then 1 square yard is equal to 9 square feet or 1,296 square inches. And then here's the conversion for square miles to square yards and square feet. Now, when we're measuring land, in English, we use acres or square miles. And then metric units. To be quite honest, I've never heard of those first two until I looked at this content. I left them on there just in case it comes up, but I did not put any questions on my lab over those because I figure if I have a math degree and I've not heard of those, I'm not real sure that you're going to use them in K through 5. Okay, square kilometers would be what I have seen, but not those first two. Okay. And then here are the conversions for those. And once again, I left the HM and the A the A and the HA on there, but I've never used them. So, okay. All right, so here's our example. We have a square field that has a side of 400 yards. We want to find the area of the field in yards. So basically it's asking you to find the area of a square. And so we just need to take the side, which is 400, and square it. 400 squared is 160,000. So I have 160,000 square yards. Now it wants to know the area in acres. So once I've got my square yards, I'm going to use my conversion chart that we saw a few slides ago. And I have 160,000, and this is in square yards. I did not put the units in there, so I will fix that. But you're going to put 1 acre on top and 4,840 square yards on the bottom because you want the square yards to be diagonal from each other. Now those will cancel out. And so when you put this in your calculator, you're either multiplying 160,000 times 1 over 4840, or you're taking 160,000 and dividing by 4,840. Same thing. That would give you 33.1 acres. Okay, then the next few slides are just going over all of our area formulas. So if there are some that you do not remember, you might want to write them down. Okay. When you're finding the area of a rectangle, you just multiply length times width. So it just means you're going to multiply the two sides together. So in this case, 3 times 4, that would give me 12 square units for the area. Now, for the area of a parallelogram, you multiply base times height. Now, what you have to be careful about here is that does not mean that you're multiplying two sides together like we did for the rectangle. Your base can be one side, but the height is probably, it could be the other side, but height has to be an altitude, so make sure it's making a right angle. If you have a parallelogram that happens to be a rectangle, you're okay. You could just multiply the 3 and the 4 because AB is perpendicular to AD. But here, we can tell these are not perpendicular. So I would need to know the height. So this H represents the height. So I would multiply B times H. Okay. Now, sometimes they may not give you the obvious altitude, like what we have here on H. Maybe they're telling you the value of G. Well, you could take this parallelogram and rotate it, and then G would be your height, but then this time A is your base. Okay, so just make sure that you look for the right angle. Okay, and whatever side it's making the right angle with, that's what you want to multiply by. Okay. Okay, kind of the same idea with area of a triangle. They drew a picture of a parallelogram here so that you can see that this triangle is half of the parallelogram. So that's why this formula for area of a triangle is 1/2 base times height. So the base times height part is the same as the parallelogram, but we're multiplying by half because the triangle is half of the parallelogram. Okay. Once again, your base is the side that the right angle is on. So here, there's my height, and here's my base. So the height might be a side of the triangle, depending on if you have a right triangle, but if you do not, just look for a side or a length that goes from a vertex and it's perpendicular to the opposite side. That opposite side will be your base, and then that length of that segment will be your height. Okay, here's a few examples. We want to find the areas of each. Now, if you look at this first one, that's a parallelogram, so I'm going to multiply base times height. You might be thinking 10 is your base, which it could be, but we don't know the height that would go to 10. What we know is this height here, coming from point D, that is perpendicular to this side, which is an extension of AB. So I'm going to use AB as my base, so it's 5, and then the height will be 8. So 8 times 5 would give you the area there, which is 40 square centimeters. Now on this triangle here, we have our height is 4, and it's making a right angle with the side that's 10. So we're going to have 1/2 times 4 times 10, which gives me 20 square centimeters. Okay. And then finally on this last triangle, we can see our right angle here, okay, goes with side AB. So the 2 is going to be your base, and then this 4 is the height, okay? So while this doesn't look like the height of the triangle, if you were to rotate the triangle to where it's sitting on side AB instead of BC, then it would be pretty obvious that this is the height, okay? So I'm going to take 1/2 times 2 times 4, which gives me 4 square centimeters. Okay, a few more area formulas. Anytime you want to find the area of the kite, you're going to take 1/2 times diagonal 1 times diagonal 2. So half of the product of the diagonals. And they're showing you here how that's related to a rectangle. Okay, so your formula is 1/2 D1 times D2, where D1 and D2 are the diagonals. So D1 is this horizontal dotted line, and D2 is the vertical dotted line. Okay, then if you want to find the area of a trapezoid, you're going to take 1/2 times the height times the sum of the bases. So B1 plus B2 are the sum of the bases. So your bases are the two sides on the triangle that are parallel. So you can see where AB is labeled as B1 and DC is labeled as B2. It doesn't matter if you switch those up. Just make sure that those are the sides you're using for your bases, not side AD and CB. Those AD and CB are not parallel, so your bases have to be the parallel sides. Okay, and then once again, that height has to make a right angle with one of those bases. Okay, here we want to find the area of the trapezoid. So we have the area of this first trapezoid is going to be 1/2 times 4 times 12 plus 16. So let's look at what that would be in our calculator. So I have 1/2 times 4 times 12 plus 16. Forgot the rest of that number, 12 plus 16. There we go. Which gives me my 56 square centimeters, sorry. Okay, the second one is a little trickier. Let me show you that on the calculator as well. So I'm going to have 1/2 again. And then this time, I don't know my height, but I know my bases are 2 and 8. Okay, so I need to figure out my height. Well, here, if this whole thing is 8, and I know this much is 2, okay, then 8 minus 2 is 6. I'm left with 6 centimeters to split between AE and FD. Okay, so each of these will be 3. Now, this only works because I have these 45-degree angles here, which makes these little triangles on each side isosceles. So if AE is 3, then that means H is also going to be 3. So that means I'm going to take 1/2 times 3 times 2 plus 8, which gives me 15 square centimeters. Okay. Now, once again, this only worked because of these 45-degree angles. Since those are the same, the base angles are the same, then that makes AB congruent to CD, and it makes me have an isosceles triangle here. So that dotted line for the H is going to be the same as FD. Okay, then the area of a regular polygon is going to be 1/2 times A times P. Now, the A stands for this dotted line here, which is called the apothem, or I've heard some people call it apothem. Okay, but it's basically the height from the center of the polygon to one of the sides, to the middle of that side. Now, the P stands for perimeter. So that's where this NS is coming from. Whatever this length is, you're going to multiply it by the number of sides to get the perimeter. Okay. Now, this only works for a regular polygon because remember, if it's regular, all the sides and all the angles are congruent. Okay. And then the area of a circle is going to be pi r squared. That makes the area of a sector. Well, if the circle is pi r squared, this section of the circle would be whatever the angle is over 360. So that ratio tells you how much of the circle it is. You're dividing by 360 because all the way around the circle would be 360. And then you're just multiplying by the area of a circle, pi r squared. Okay. So any of those area formulas that you do not know, I would have those written down so that you'll have those handy while you're working on the MyLab assignment. And then that'll also help you get a start on your page of notes that you can use for the last test. Okay, reach out if you have any questions.